Welcome back to the VAB. Today we're going to take a look at probe cores and command pods. So we're familiar with the Mark 1 command pod. We've used it on a few missions already, and I want to talk a little bit more about it. What does it do for you? Besides being somewhere for your Kerbal to sit and a protective shell to protect them from the fire of re-entry, what does it do? Well, to get an idea of what the command pod contains and is capable of, we're going to hover over it in the menu here and right click. And if you don't see this part, right click again. The main part of this data block tells us it's some basic stats. It's mass, tolerances for impact, and g-force and temperature. And that tells us how sturdy the ship is. Is it going to handle landing from free fall, or is it going to be able to handle re-entry heating? What else the command pod does for us is it provides steering. As I said in previous videos, the reaction wheels in the equipment within this command pod is what allows us to steer the ship. So in order to steer the ship, we need one crew, and it has to be a pilot. And we have reaction wheels, and that's what lets us steer. Along this side, we have a whole bunch of other characteristics, you could say, of this pod. It's a cargo part. It cannot be placed in storage. That makes sense, but it can be manipulated in EVA construction, which is something you'll unlock later. Command. Minimum crew to operate 1. Crew must include a pilot. If you don't have a pilot, if you just have a scientist in there, it's not going to work. It has a data transmitter, so you can talk to it, but it won't transmit science. So if you want to take a science report and send it back to Kerbin, you're going to need to add a supplemental antenna. It has an inventory slot that you can put something in that an engineer might be able to use up in orbit. It has a lifting surface. That really just means this big bell shape will provide some drag and you can steer the ship a little bit, but that's for more serious players than I. The reaction wheels themselves, they have pitch, yaw, and roll. 5 units. I don't know what 5 means. That's an internal game mechanic, I think, but it just means that it has 5 units of control. You'll see other parts might have less. Let's see, this one. Yeah, this guidance unit only has 0.5. So this remote guidance unit only has 10% of the steering capability that this command pod does. And then consumables. Electric charge and monopropellant. So those reaction wheels, they require electricity, 0.2 units per second. And the electricity, it comes from the electric charge. You can also attach things like solar panels or fuel cells or batteries to the command pod to expand the electric charge and provide a way of recharging your batteries. And then monopropellant is a little cold gas that's compressed and it's stored, and it would come out of these little thruster blocks. So these blocks would be, you could place them on the outside of your ship, and that would let you, it would help you steer the ship and move it sideways, side to side, up and down, back and forth, what have you. So this pod has some of that monopropellant gas stored within it. We can compare that to the Mark II version. So we'll take this one away. The Mark II version, which we haven't encountered yet, is bigger. We have capacity for 2, but it does not have monopropellant. So if you're planning a spaceship that's going to use monopropellant, let's say to dock with another ship, you're not going to be able to use this pod on its own. You're going to have to go and find a fuel tank that has RCS fuel, monopropellant, and you're going to have to add that to your ship. And now you have 20 units of monopropellant. Huzzah! So the other command pods here all have different capabilities and uses and strengths and weaknesses. So we've talked about the Mark 1 command pod, a little bit of Mark 2. The Mark 3 is yet another advancement. We haven't seen the Russian style spherical ones. These ones operate a little bit differently. When we check them out, we notice that they don't have reaction wheels, so you can't steer with this one. You need to add another part or another capability or another method of steering the ship. However, it has its own decoupler. So you see ejection force there. It means it can decouple itself without an extra part. And it has a blader, which means it is its own heat shield. These little hexagonal, this hexagonal pattern, I guess, is designed to be a heat shield. So it'll be able to handle higher reentry heating and reentry forces. It's a little bit of a trade-off. No steering, but it'll separate on its own, and it has a heat shield kind of built in. The other parts here, you have some spaceplane cockpits, which are really useful for when you decide to start building aircraft instead of just rockets. We have lander cans. So these are little cans that are much lighter than the command pods that we've used before. So this one is almost a ton. This one is just over half a ton, which means it's much more efficient to take this down to the surface of the moon or something like that, because we won't need as much fuel to get it back off the moon. And it gives us lots of nice attachment points where we can put our landing legs. Well, we should probably use 4 of them, hey? There we go. Put our landing legs on the side. We can put a little, let's see, a tiny little fuel tank underneath. And maybe a wee little engine. And then we can go land this on the moon. Also, we have probe cores. These are the things. These are what you'd use to develop satellites, something like that. Because the basic version, it has stability assist, so it'll stay pointed the way you steer it. It has an electric charge. It has reaction wheels, so it can steer, it can orient. It's just not very advanced. It'll just stay put. Whereas the advanced version, super advanced version, has all your normal autopilot abilities, so you can do some pretty advanced maneuvering with this probe core that might be a lot harder with the basic one. Wrapping up, we have the remote guidance units, and these are like probe cores, but they're designed for rocket stages. So let's say we had a rocket, and we knew that one part of the rocket, let's say this part, not that part, this engine stage was going to get left in orbit. This stage was going to take us all the way into orbit, and then we're going to detach our pod or our satellite, but this stage is going to stay in orbit. We don't want to just leave it in orbit, we want to deorbit it. So we can use this little remote guidance unit, attach it to this rocket stage, and when it detaches from our command pod, we'll be able to go back and control this rocket autonomously without any Kerbals on it. And then we could flip it around and burn the engine and have it re-enter the atmosphere. So that's the a common use of these probe cores. It's also handy if you want to have an unmanned vehicle. So let's say you build a lander. Let's say a lander can. Yeah, there we go. And you have it set up to dock with your main ship. But you don't have a Kerbal in there. So what you can do is go back to pods, put a remote guidance unit on the bottom. And now you'll be able to control this ship without a Kerbal inside, which will make it much easier for you to intercept it and dock with it and take it off to the moon and back. So I hope that was a useful rundown of some of the command pods and probes, autonomous devices, the parts that you can use to build your ship. If there's any doubt, just go right-click the part, read up on what it can do for you and what it has available to it, and design away. Thanks for tuning in.